Okay, problem number 10. Problem number 10 is termites and spiders. So apparently you're going to move into this house, and whoever inspected this thing did not find that it is infested with termites and spiders. So it says the day you move in, so there's a bunch of termites. So we're going to make a little chart here, which will be helpful for us. So termites, spiders, days, okay? And on day 0, so the day you move in, there's 100 termites, right? And then you got day 1, day 2, 3, 4, 5, 6, 7. We're going to need to go down to 8 on this little chart here. Okay, so it basically says after 4 days, there's 200 termites. So after 4 days, there's 200 termites, right? But after 3 days moving in, there are 2 times as many termites as spiders, all right? So that means if we call this S3, so spiders on day 3, there's 2 times as many termites as spiders. So if I take 2 of the number of spiders on day 3, I get the number of termites. Okay? Now, we also know that 8 days after moving in, there are 4 times as many termites as spiders. Okay? So 8 days, so S of 8, there are 4 times as many termites as spiders. All right? There we go. So that's enough information. How long in days does it take the population of spiders to triple? Okay, well, we're going to start off with the termites because I have 2 data points. I got this data point right here, and I've got this data point right here, and that's enough to come up with an equation. With that equation, then, I can solve for day 3, and then I can take 1/2 of that number and get the spiders for that day right there. Once I get that, then I can start backtracking and figure out what the heck is going on to get my spiders. All right, here we go. Yeah. All right, here we go. So, here we go. 200 equals 100b to the 4. So, 2 equals b to the 4th. So, 2 to the 1/4 power equals b. All right, well, 2 to the 1/4 is 1.189. So my equation is 1.189 to the x, and that is termites, right? T of x. Got it. Okay, now, if I want to know the number of termites on day 3, I plug in a 3. Ooh, that's electric. There, and I go about solving that. So 1.189 to the 3rd turns out to be 168. Now and that's this number over here. Okay, well, if I take half of that, that means there are 84 spiders on day 3. Okay? All right. Now, we also know that 8 days after moving in, there are 4 times as many termites as spiders. Okay, so if there are 4 times as many termites as spiders, then I should be able to get my SO and my spider function. And so here we go. I've got SO b to the x is my general function for the spiders. Now, if I say, if I can figure out how many spiders there are on day 8, then I'll be in business. So here we go. If I take 100 back to the termite function, 1.189 to the 8, and then I'm going to divide that whole thing by 4, right? Because that's how many spiders there are. If I divide all that by, there's 4 times as many termites as spiders. So here we go. Do a little quick calculation here. Okay, well that top number turns out to be 399.4 divided by 4, so I'm just going to round that to 100 termites. Okay? So we know that there are 84 termites on day 3, and there are 100 termites on day 4. So if I take this equation, and now I have 2 data points, I can solve for my initial, which I'm going to have SO b to the 8 equals 100 divided by SO b to the 3 equals 84. All right, now divide off the SO, I can get the b value. And so b to the 8 minus 3 equals 100 over 84. B to the 5th equals 100 over 84. Take the 5th root, and that gets me a b value of 1.035. Cool. Now if I plug that back in, I will end up using that 100 number equals SO 1.035 to the 8. So I'll use this set of numbers here to solve for the SO value. That's just a number divided into 100. The SO equals 75. This is a crummy house, man. You got 100 termites and 75 spiders right on the get-go. All right, so when will this thing triple? Well, we'll use our little 3 initial values times the initial value of the b, 1.035 to the x. Take the natural log both sides, divide it by the base. And we end up with 31.9 days. So 1 month in, holy smokes, we had 75 spiders times by 3. So that's 150 would be 2 plus another 75, so 225 spiders. Anybody seen the movie Arachnophobia? Yeah, we're getting close. All right, now I have some news for you. Problem 11 is kind of crazy. So for now, I just want you to do, we're just going to look at part A. And then we'll go from there. So here we go. Let's do, let's just make this, we'll just make this all nice here. Okay, 12 11. Here we go. So, what is the initial voltage output of the circuit? Well, we're going to have a VT equals 2 to the 3 times the sine of 5 pi t minus 3 pi plus 1. Okay, well the initial, I'm going to plug in a 0 there for my t. So I end up with 2 times 3 sine of 0 minus 3 pi plus 1. Okay, well in radian mode, if I subtract 1 pi, I'm over here at 180 degrees. Subtract 2 pi, I'm over here back at 0. Subtract 3 pi, I'm over there again. And so if you take the sine in radian mode, three times the sine of negative 3 pi plus 1. So the sine of negative 3 pi you end up with 0, which that would make sense because the angle measured in here is a straight angle, so it's 0. So I get 3 times 0 is 0, and I end up with an exponent of 2 to the first, so I get 2 to the 1, which is just 2. So the initial voltage out of this thing is 2 volts. Now you'll see that there's no answers to number 11 in the back. That's actually wrong. The answers they're giving you in the back for 11 are actually for 12, and the answers for 12 are for 13. Okay. Part B, will it ever get to 0? No. Part C, they want you to graph this thing, and so graphing calculator would be helpful. Over the interval 0 to 1, they want you to graph this that part in here, the sine 3t job 3 sine deal. And as far as I'm concerned, we're just going to cut problem 11 out. So if you did it, good job. If not, good job, because we're going to skip it. All right, moving on to 12, next recording.